Hey everybody, today we are starting percent composition. And what percent composition is a method for figuring out what percent an element makes up of a given compound. For example, in carbon dioxide, this allows us to figure out how much of carbon dioxide is carbon and how much of carbon dioxide is oxygen. So we can kind of break down how much each element contributes to any compound. And how you solve for percent composition. You take the mass of a specific element or compound, so whichever one you want to know about, we'll say in this situation carbon, you would take the mass of carbon, you would put it over, or you would divide it by the total molar mass of the compound, and then you would multiply that number that you get by 100, and that's going to give you the percent composition of whatever element you are dealing with. So for the purposes of this first example, let's look at carbon dioxide, and within carbon dioxide we're going to look at carbon. So the first thing you need to do, the very first step for percent composition, is calculate the molar mass of the total compound. So in this situation, carbon dioxide, we have one carbon, and that one carbon is 12 grams per mole. And then we have two oxygens. So one oxygen is 16 grams per mole. We have to multiply that times 2 because we have two oxygens. So 16 times 2 is, of course, 32. 12 plus 32 is going to give us a total molar mass of carbon dioxide of 44 grams per mole. That is always the first step you will take, is figuring out the total molar mass of the compound you are dealing with. If you don't get the total molar mass right, then the rest of the problem will not work out. So now that we know our total molar mass of carbon dioxide is 44 grams, let's try to solve for the composition of carbon. Like, what percentage of carbon dioxide is actually carbon? That's what I want to know. So we look at our setup up here. You have to take the mass of the element you want to know about over the total molar mass. So we want to know about carbon. Carbon is worth 12 grams per mole. So we would put 12 right here. And we're going to put that over the total molar mass of the compound. In this situation, the total molar mass of our compound, carbon dioxide, is 44 grams per mole. So we do 12 over 44. Then when we do 12 over 44, we'll multiply our answer times 100. So that is a very straightforward equation there. You see I get the 12 because that is the mass of the specific element that I want to know about, and then I get 44 because that is the total molar mass of carbon dioxide. So I do 12 divided by 44. It's going to give me that times 100. So my percent composition of carbon, the percentage of carbon dioxide that is made up of carbon, is about, if I round it, it is 27%. So in any given molecule of carbon, any given molecule of carbon dioxide, 27% of that molecule is is carbon. Let's do another example. Let's do water. So we have H2O. So we have H2, it is 1 gram per mole for every H, so you have to times that by 2, and then oxygen is 16 grams per mole. Added together, the total molar mass is 18 grams per mole. And I want to know percent composition of, we'll go with hydrogen. Percent composition of hydrogen. So first step, we already accomplished our first step, which is figuring out the total molar mass, which is 18 grams. Now I want to know the percent composition of hydrogen. So what do I do next? I have to take the mass of whatever element or compound I'm dealing with, which in this case is H2. Because hydrogen, it's not just 1 gram per mole, it's H2O, so I have to do 2 grams per mole. You have to do the total mass of whatever element you're dealing with. So I would do 2 grams per mole because that's how much hydrogen is found in every water molecule. So I'd do 2 grams per mole over our total molar mass here of 18 grams per mole. 18, and then I'll multiply that times 100 to get my final answer in terms of the percentage of each water molecule that is made up of hydrogen. So I would do 2 divided by 18 times 100. So every water molecule you see is approximately 11% hydrogen, meaning it's about 89% oxygen. So that's kind of interesting. Water is mostly oxygen. Even though there's two hydrogens, it's still primarily made up of oxygen. I'm going to do one more example for you, and then we will be done. This time let's do N2H4. So dinitrogen tetrahydride is what we're going to do right here. So my very first step, figure out the total molar mass. Go ahead and figure that out on your own. We have N2, so it's going to be 14 grams per mole times 2 for a total of 28 grams per mole of nitrogen. And then hydrogen, you have H4, you have 1 gram per mole times 4, so that's 4 grams per mole for a total molar mass of 32 grams per mole. So that's our total molar mass. That's our first step. Now the question I'm going to ask this time is I want to know what percentage is nitrogen. Percentage nitrogen. So first I got to set up my proportion or my fraction here. On bottom I put my total molar mass, which here is 32 grams per mole. On top I have to put however much nitrogen is found in this compound. So in this situation it is N2. Therefore, I have to put 28 grams. Remember, I'm putting the total amount of that element that is found in the compound. So 28 grams is found in the compound. So I would put 28, and then I'm going to divide that and multiply it by 100, and it's going to give me the percent composition of nitrogen in N2H4. So 28 divided by 32 times 100. 28 divided by 32 equals times 100, about 87.5%. 87.5% of this compound is made up of nitrogen. So even though there's 4 hydrogens and only 2 nitrogens, still 87.5% of the compound is made up of nitrogen. So that is percent composition. If you have questions, as always, just ask. Farewell.